Chapter 5.3, Determinate Solutions for a System of Equations. Every square matrix has a real number called a determinant associated with it. Remember, we mentioned that it's important to enclose your matrices with brackets. That's because determinants are enclosed with vertical bars. The determinant of a 2 by 2 matrix is found by cross multiplying. So I would say this times this minus this times this. For example, if I wanted to find the determinant, so I'm going to put it in vertical bars as opposed to brackets. That means something specific. It means I'm evaluating the determinant. I would say 2 times 5 minus 3 times negative 1. Or 10 plus 3. The determinant for this 2 by 2 matrix is 13. We can do a similar thing to find the determinant of a 3 by 3. I'm going to rewrite the matrix by adding the first 2 columns again. That way I have enough where I can multiply this, 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 and then do minus this, this, this. Right, a 2 by 2, we cross multiply this times this, minus this times this. On a 3 by 3, we're going to have 3 rows, diagonals, I guess, minus the other 3 diagonals. So let's see if we can do this and kind of keep track of what we're doing. All right, so this is going to be 2 times negative 4 times 2, so negative 16, plus negative 3 times negative 3 times negative 1, so plus negative 9, plus negative 2 times negative 1 times 0. Okay, and then minus negative 3 times negative 1 times 2, so 6, plus 2 times negative 3 times 0, so 0, plus negative 2 times negative 4 times negative 1, so minus 8. So we would have negative 25 minus negative 2, right? Negative 25 minus negative 2, or negative 25 plus 2, so negative 23. Every square matrix has one number associated with it that we can find with this determinant method. Okay, let's see why we would want to do that. because we have something called Cramer's rule. Cramer's rule gives us another method to solve a system of linear equations. Okay, and here are your steps. The first thing we're going to do, let's say I'm trying to solve this system and I'm going to use Cramer's rule. The first thing I want to do is I want to make a matrix of the variable coefficients. So I'm going to make a matrix, a square matrix, using just the coefficients of the variable. Okay, and I'm going to find its determinant. I'll just call that D. So D is going to be the determinant from my variable coefficients. So negative 35 minus 12, or negative 47. Okay. Then I'm going to make a matrix where I replace the coefficients of the x variables with my solution numbers. Okay, I'm going to call that determinant d sub x. So I'm going to find the value of the determinant for this matrix to be negative 70 minus 24, or negative 94. Now I'm going to make a matrix where I replace the coefficients of the y variable with the solutions. And I'm going to call that d sub y. So if I have, I'm going to call its determinant d sub y. I'm not going to call that matrix d sub y. So evaluating this determinant, I get 30 minus 30, or 0. Now, the reason we want these values is because the solutions to this system can be found with the x solution being d sub x over d. So negative 94 over negative 47, or 2. And y is d sub y over d, or 0. So there's my solution. X is 2, y is 0. So just another method to solve a system of equations. Okay, if your determinant D is 0, you can't use Cramer's rule. But what that's telling you is that either your system has no solution or infinite solutions. So you'll know that piece of information, and you can go back and use one of the other methods to determine if it's a no solution or infinite solutions. Because of course you can't divide by 0, and we've got to divide by that D. Okay, so let's try that again. This time, let's do a system of 3 equations. So the first thing I want to do is find the determinant D for the square matrix formed by the coefficients of my variable terms. Okay, so in order to do that, I'm going to rewrite my values and add that first column again and then that second column. All right, so then I'm going to get 2 times 2 times 2, so 8, plus -1 times -1 times 1, so 1, plus 4 times 3 times 4, so 48. And then it's going to be minus -1 times 3 times 2, plus 2 times -1 times 4, plus 4 times 2 times 1. So I have 57 minus 6, or 57 plus 6. D is 63. Okay, I'm going to do the same thing that we did previously to find D sub x. I'm going to replace the x values, the x column, with the solution column. The y's and z's stay the same. All right, so to find this determinant, I'm going to write these values. And add the first two columns again. Okay, so this is going to be -2 times 2 times 2, so -8, plus -1 times -1 times 17, so plus 17, plus 4 times -3 times 4, so minus 48, and then it's going to be minus -1 times -3 times 2, so positive 6, plus -2 times -1 times 4, so positive 8, plus 4 times 2 times 17. Okay, so 17 times 8, I have to go over here and do that. 136. Yeah, positive 136. So we wind up with, let's see, 17 minus 8 is 9, minus 48. So negative 39 minus 136 plus 14, 150. So this is negative 189 All right, so now I've got negative 189. And I'm going to do the same thing to find my d sub y. I'm going to replace the y column with the solution column. So 2, 3, 1, negative 2, negative 3, 17, and 4, negative 1, 2. All right, so I'm going to come over here and write the values just as they are. But then we're going to add those first two columns again. Okay, so I have 2 times negative 3 times 2, negative 12, plus negative 2 times negative 1 times 1, plus 4 times 3 times 17. So what do we have? 12 times 17. So 204 plus 204. And then it's going to be minus negative 2 times 3 times negative 2. So negative 12 plus negative 34 plus negative 12. So 194, right? Let me see if I did that right. That would be negative 10. So 194 minus 58. Double check my math there. 24, yeah, minus 58. Oh, minus 58. Watch your signs. I've got a minus here. And then that's all negative. So 194 plus 58 is 252. Okay, so this is 252. And then I'm going to do the same thing with my z's. I'm going to replace my z coefficients with the answers. So 2, 3, 1, negative 1, 2, 4. Now put the solutions, negative 2, negative 3, 17. And I'm going to come over here and write that. And add the first two columns again. Okay. So 2 times 2 times 17. 17 times 4, 68, plus 3, right, plus negative 24 minus negative 51 plus negative 24 plus negative 4. So you might also notice something, we could have done that up there too. If I go ahead and distribute that negative, just, try to make your math as easy as possible. Then there's a plus 24 and a minus 24. Right? So I have 68 plus 3 plus 51 plus 4. So 68, 71 plus 55. 71 plus 55. Or 126. Now, once we have all these values calculated, then x is d sub x over d, right? D sub x over d, or in this case, negative 3. Y is d sub y over 3. Or in this case, is that 4? Yeah, 4. And z is d sub z over d, or 2. So there's our solution. Negative 3, 4, 2. X, Y, Z. Found using Cramer's rule. All right, let's see if we have another one. Right, one more. Let's try that again. Okay, D is going to be the coefficients of all my variables. So I'm going to write that matrix, or not the matrix, the values in the matrix over here. And add the first 2 row columns again. Okay, 1, 4, negative 1, 2, 3, 2. Oh, just double checking, and I'm glad that I did. Okay, 3, 2, negative 3. So 1, 4, negative 1, 2, 3, negative 2, 3, 2, negative 3, 1, 4, negative 1, 2, 3, negative 2. Okay. So we have negative 9 plus negative 4 plus negative 24. And then it's going to be minus negative 24 minus 4 minus 9. Okay, I see that this one will be a lot easier to add if I distribute that negative, because look what I have. Plus 24 plus 4 plus 9 minus 9 plus 9 minus 4 plus 4 minus 24 plus 24 equals 0. If the determinant for your variable matrix is 0, then you're done with Cramer's rule. you now have to go back and decide, is it a no solution or an infinite number of solutions? So when I look up here, I notice, oh, look at this first equation and the last equation. It's basically the same equation, except if I would multiply a negative through here, right, then I'd have the exact same equation, except this is equaling -4, where this one equals 0. That's a no solution problem. I can't have the same equation equaling two different answers. Okay, so determinate solutions to a system of equations. Practice that and let me know if you need any help.